angles of elevation and depression for question 8. Vertical building stands on level ground, ABF, AB is 80, are all the information given in the diagram. So for this type of question, we always like to simplify it, get rid of all the irrelevant information, make sure all those that are relevant are inside. T, F, B, A, and AT. So out of all these things, the right angle was not drawn in your diagram. So that is what you're expected to do, because it says a vertical building standing on horizontal ground. Vertical on horizontal definitely means that they are perpendicular to each other. So 90 degrees over here. And what else did it say? Angles of depression of A and B from T. So where is our reference? Where is the person's eye? Is it an A, B, or T? Okay, let me choose somebody to ask. Xiao Wei, where is the person's eye? You have 3 seconds. Please stand up. Stand up to answer. Okay, you have 5 seconds to answer. If you don't answer, means you don't know what's happening. 5, 4, 3, 2, 1. What? A. The person's eye is at A. Can you explain why you say that? Or was the answer provided by Yang Kun? Then does Yang Kun want to help? Okay, he shall remain standing. Let's have his buddy, Yang Kun. Can you please stand up and answer the question? Where is the person's eye? Where is the person's eye? At A, why? Sorry? Angle of elevation. So the person's eye is at A. Okay, you shall remain standing as well. Let's go down the row. Alfian, where is the person's eye? Please stand up and answer. Stand up and answer. A. Why? Okay, taking too long. Boyi, please stand up. Where is the person's eye? The person's eye is at T, because we are looking from T. Okay, everybody got that? The person's eye is at point T. And he's looking up or down? Down, right? Okay, Boyi, you can sit down. Let's try Alfian. Where do we measure the angle of elevation from? I mean, where is the... You know, if you want to measure an angle, right, it's always between two lines. Okay? Right? If you want to measure angle, it's always between two lines. So what are the two lines? Xiao Wei and Yang Kun, you can answer that also if you have the answer. Okay. The person's... he's looking down, right? So there is an angle of depression. And in the question, they said that the angle of depression of A from T is 32 degrees. Where exactly is this 32 degrees? BAT? Why? Why? Are you sure we measure the angle this way? This one being 32 degrees? Is that what the three of you are saying? Is this how we find the angle of elevation? Or depression? Yes or no? No, okay, Yang Kun says no. Why? So where should we start from? Huh? Draw a line. What kind of line? Okay, the three of you discuss. Give me one answer. Where is this 32 degrees? Yeah, he's looking now. Shall we? Any idea? Don't know where is 32 degrees. Who doesn't know? Who else sitting down doesn't know where this 32 degrees is? So all of you know. Then it just so happened that the three of them don't know. What line? horizontal line. If you say draw straight line, then I draw a straight line like that. Right, straight line, right? So we need to draw a horizontal line. Okay, then what do we do? So the angle of depression is from the horizontal, the person's eye is over here, from the horizontal to the line of sight, right? It's looking down at point A. So this is my angle, it is 32 degrees. Okay, thank you, all three of you can sit down. Okay, so sit down. This exercise, right, I want you all to use the correct terms. So what you all gave me was the horizontal. Okay, can't be just any straight line. Horizontal, from where? From the person's eye level. Where is the eye level? At point T. Okay, then they also told me that, hey, the 32 degrees is over here. Is this right or wrong? Is this correct or wrong? It is actually correct, but the definition of angle of depression doesn't say from the ground level to where the person's eye is. Okay, the definition is always from the horizontal over here to the line of sight. So even though this angle over here, it is indeed 32 degrees, we know that it is true because of which property? Huh? What property is this? How can you be so sure that this is also 32 degrees? Okay, Z. What is that? Z. You know it is Z, then you need to finish, you need to complete memorizing it. What kind of angle is it? Huh? Alternate angles, yes, I heard it already. So this line and this line, they are parallel because they are horizontal, right? So they are parallel, and this angle 32 must mean that this is also 32. They are alternate angles on parallel lines. Okay, so now that we have one piece of information, this is 32 degrees. Can you tell me where is the 43 degrees now? Shafiq, can you tell me where is this 43 degrees? Where is 43 degrees? You come over here and draw on my tablet. Come here and draw. So I've got 32 here already. Where is 43?
It's until the B.
Draw lah.
Until there.
Okay, thank you. So this is what he drew over here. This is 43 degrees. Okay, since this is 43 degrees, then this must also be 43 degrees. Okay, same reason, alternate angles. Any questions so far? Okay, then let's start. Find the distance AT. So AT is over here. How do we find AT? Well, any other information that we had? Okay. Let us put in all the other angles first. Over here we also have 32 degrees. And here we have 43 degrees. How to do this? Okay, let's put in some trigonometric ratio first. What I can come up with will be TF is a common line, right? So let me try forming an equation with this triangle. T, F, A, this one 32 degrees. Okay? This one right angle. Doesn't work. Oh, okay. I see. Does anybody know how to do this? So how you managed to do it, right? Okay, let me see whether my method is the same as yours. I will want to find this angle first. Okay, so this angle ATB, is equals to 43 degrees minus 32 degrees, and that gives me 11 degrees, right? So over here I have 11 degrees. Okay, then let me draw this triangle. This is 80, 32, 11 degrees, and this is my unknown, A, B, and T. Okay, what do you think I need to do next? I need to find the unknown angle over here. Angle ABT is equals to 180 degrees minus 11 degrees minus 32 degrees. How much is that? How much? 137 degrees. Angle sum of triangle. So now that I know this is 137 degrees, doesn't that mean I can find my value of AT? Which rule do we use? Sine rule. Okay, so AT over sine 137 degrees equals to AT over sine 11 degrees. Then you can solve it yourself. AT equals to something, round it off. 3SF. Okay, I was stunned for a while because I couldn't do it. So this kind of feeling, right, you all may also experience it during our exams. I need to keep calm and try to think. I'm doing this question for the first time, by the way. Say again? One question I haven't shown. Which question? What is it? One part, which part? Hey, Klu, can you hear what he said? Could you all hear what he's saying? Yeah, everybody cannot hear what he's saying. Some part, which part? 12A? You mean this exercise? Question 12? Oh, okay. Okay. Okay, now let us move on to part B. The height TF of the building. How do we find the height? So this is now our unknown. And we have the length over here. And how much do you all get for AT? .285.93 meters. Okay, then are you able to find the yellow color region yourself? I'm sure you can, right? Just use your opposite and hypotenuse. So sine 32 degrees equals to opposite, which is TF, over your hypotenuse, which is your AT. Get the answer? Oh no. Then TF will be equals to AT sine 32 degrees. Get an answer, round it off to 3SF. Okay? Right, let's move on to question number 9. So, helicopter. Okay, angle of elevation of H from A. So the I is over here. It's because it's from A. Angle of elevation of H. We look from the horizontal, we look up. So this is 37 degrees. Then after that, we put another I over here. he's looking at the helicopter, and this is the horizontal. This being the horizontal, looking up, this will be 43 degrees. Okay, so this is where the angle of elevation is. Find the distance AH. This is what we need to find out. I think we can find what is the angle AHB first. Angle AHB equals to 180 degrees minus 37 minus 43 degrees. Angle sum of triangle. That gives me 100. So again, I'll use my sine rule. Okay, AH over sine 43 degrees equals to 250 divided by sine 100 degrees. So AH equals to 250 sine 43 degrees divided by sine 100 degrees. Get an answer, round it off to 3SF. Once we manage to find AH already, then we can do part B quite easily. This is A and part B. Okay, simple trigo. I'm not going to tell you the answer already. Right angle triangle, decide which ratio to use. What's the next question? 12. Okay. Okay, vertical buildings, 15 and 24 meters. Find the distance BC and AC. Any more information given? Okay, since AC and CE are equal, let AC equals to CE equals to Y. Okay, they're the same thing. So instead of writing so many things, let's just call it Y. And let us have BC equals to X. So over here we have X. What will then CD be? If BC is X, what is CD? 27 minus X. 27 minus X. Over here. Let's see what we can do with this. We have we have two right angle triangles, right? So let us form an equation with this triangle on the left first. Let us use Pythagoras to form an equation. So on the left hand side, y square equals to 15 square plus x square, right? And then for the other triangle, I have y square equals to 24 square plus 27 minus x square. Yes? Anissa, okay? Are you able to form the two equations? Okay, so do you understand this equation? From this yellow color triangle, it is a right angle triangle. So using Pythagoras theorem, the square of the hypotenuse is going to be the sum of the square of 15 and the square of x, right? And the other triangle, also right angle triangle, I form another similar equation. Hypotenuse squared equals to 24 squared plus 27 minus x squared. Correct? Okay? Then, since I have two equations, let's proceed to solve them. Equation 1 and equation number 2. What do you want to do? Do you want to use elimination or substitution? Up to you lah. What do you prefer? Elimination? Let's try equation number 2 minus equation number 1. Then what am I left with? 0 equals to 24 square plus 27 minus x square minus 15 square plus x square. Right? This is elimination. Therefore, 24 square plus 27 square minus 2 times of 27 times x plus x square minus 15 square plus x square. So this one is a minus equals to 0. Can follow this step? It's just expansion. Copying down the answers is one thing, but make sure you understand. No point you copy already, you go home, you look at it, you still don't know what's happening. So I'd rather you understand in class already, go back, watch the video and copy down the answers. Anyone can understand? Which part don't understand? You mean, okay, let's go back. Are you able to understand this equation? Someone can? Oh, okay. It is just simultaneous equations. You have two equations, equation number 1, equation number 2, right? How do you solve them? How many methods do you know for simultaneous equation? How many methods? What are the 3? Substitution, then elimination and graphical. Right? We're not going to draw a graph over here. So it's either elimination or substitution. Choose one method that you like. In this case, I use elimination. Equation number 2 minus equation number 1. You can also use substitution if you want to. And you will still get the same answer. Okay? So from here, next step is that we realize x squared and x squared will cancel out. So I'm only left with one unknown. Negative 54x plus 24 square plus 27 square minus 15 square equals to 0. Solve for x. Okay? Any questions for this one? Why would it be negative? No, it looks like it's going to be positive to me. Okay, let me work it out for you. 54x is going to be 24 square plus 27 square minus 15 square. Okay? Why got 2 what? Why got 2 27 square? This one? Why? I expand this one, no? You mean this one? Because 27 minus x you square, you get 27 square minus 2 times of 27 and x. Okay, the highlighted part, this one and this one, they are the same thing. Let me elaborate. You know that a minus b square equals to a square minus 2ab plus b square, right? So we are using the same thing. 27 minus x square. 27 minus x square equals to 27 square minus 2 times of 27 times x plus x square. Okay? Any more questions? Any more questions? Yes, Yang-kun, do you have one? How do you do it? AC equals to CE and then? Show me. 24 square plus plus. Where is your x?
Square is the easy.
Okay, then CE square equals to 24 square plus, why 27x square? That's not wrong. It's 27 minus x square. So who did this for you? This is not your handwriting. Sure. Okay, so it's the same thing. Yeah. Everything is the same.
A bit different.
How is it different? 15 square plus x square equals to... Yeah, basically this is this type. See, they are the same thing. Same. Okay, any questions? X is 20. This is actually equals, in my question, I let x be equals to BC. So BC equals to 20 meters. Okay, then you can find CD by AC by yourself. AC is equals to y. And we're able to find y from here. Right, using y square equals to 15 square minus plus x square. Y square equals to 15 square plus x square. So y square is equals to 15 square plus 20 square. Y equals to square root of 15 square plus 20 square. This is equals to AC. So get the answer. Round it off if you need to. Okay? Can I move on? Who needs more time? Raise your hand. Who is missing from 4 dynamic? Darren, Ali. Where's Darren? Yesterday he wasn't here also, right? Anybody knows what happened to him? And Ali. Anybody else? Tina. Okay. Mars is here. Okay. Okay. Angle of elevation of E from C. E from C. So where's the person's eye? Here the person's eye is at C. And he is looking up at E, right? So from the horizontal, looking up, this is the angle that they want. We already have the value for Y, we have the value for X. So you can just form any trigo ratio you like. You will be able to get an answer. Okay? Up to you to choose. Now question 13. What? So B already told you. You already know this value of Y, you know the value of X, and given a right angle, triangle, you can find the angle yourself. Using any trigo ratio you like. Okay, question 13. Has anybody been to the Leaning Tower of Pisa? Anybody been? The building is really slanted. You know why? I never been there before, but it's really slanted. It's not meant to be slanted. They built finish already, right? Then it started to slant. Then they don't know what to do. Because they don't want to demolish. Build so long, then it's slant, but still safe, then now it become an attraction. Yeah, it's still slanted. I think it's just hollow inside. I'm not very sure. Huh? Yeah, the building is slanted. Oh, it's hollow. You been there? Then how you know? Oh, you read up about it. When do you go Google? In lesson? Okay. Yeah, it's hollow inside. So this is 4 degrees. This over here, in red color, this is my tower. Okay? It is 4 degrees to the vertical, so this is my right angle over here. Let me just include everything else. B, C, 51.1, 28 degrees. This is T. What is NA? Oh, from NA. Did I get everything? Oh, this is 46 degrees. Any more angles that I can include? I think there's some more, right? Let us just include some quickly. This will be 134 degrees. So using some angles on a triangle, this will be 18 degrees. Any more that I can have? This one also, right? Wait, do I know that? No, I don't know that. How do I know? Oh yeah, I can find out this one. Because I can consider the huge triangle. So ATB is equals to 180 degrees minus 90 degrees minus 28 degrees minus 18 minus 4 degrees. I'm not sure whether these will be useful or not, but let me just calculate them. So this will be 40 degrees. Then else can find this angle. This is 94 degrees. And this will be how much? 86? Okay, so you see that it is possible to find every single angle in this question. I don't know which one is useful yet, so let's see what we can do. Find the distance TC from T to C. I can use my sine rule. If I just consider for part A, T, B, C, this is 51.1, 134 degrees, and I have an angle here 18 degrees. So therefore, TC over sine 134 degrees equals to 51.1 over sine 18 degrees. Solve for TC. Okay? Any questions? Then let's find the height of Tn. So given TC, we have it already. We draw another triangle for part B. Let's use this triangle. T, N, and C. 28 degrees. We already have TC. Right, so I can find Tn using sine 28 degrees equals to Tn opposite over hypotenuse, which is TC. TC was already found. Substitute. So you can find Tn. For Tn equals to TC sine 28 degrees. Get an answer, round it off. 3SF. Then now they want the height of the tower, which is TA. To find the height of the tower, this red color line, we draw one last triangle. Part C, T, N, and A. This being 4 degrees. We already have this from part B. So I can find TA. the red color one that I was talking to you about. So cosine 4 degrees equals to Tn over Ta. And Ta will be equals to Tn over cosine 4 degrees. And Tn, we already had it from here. So get an answer, round it off, 3SF. Okay? Am I going too fast? Which one? Part C, okay. Before that, part B, anybody needs me to recap? Rewind? No, all busy copying. Did I give you all some time first? Okay, part B, anybody needs help? Explanation? Otherwise, just for part C, back to our original diagram, Rabiatul. For part C, this is our original diagram, right? And we want to find the red color line, the distance for the red color line, right? We already had Tn from part B, right? So we have this already. It is a right angle triangle. So I only need to look at this triangle over here. So that is a right angle triangle with an angle of 4 degrees here. Given the adjacent of an angle, I can find the hypotenuse using cosine. Okay, anybody else needs help? You find T B. Okay, and then what did you do? Oh yeah, okay, you can do that also. But I think this one might be a bit shorter than yours. Okay, so this is it for our homework 1.2. Just like the previous piece of homework, you have today to finish your corrections and submit it to me tomorrow. Okay, tomorrow we don't have lessons, but I still need you all to submit it so that I can go through it. Okay, submit it to your math rep, Francis. Then he will put it in my pigeonhole before the end of today. Francis, same thing, the post-it, write down who didn't submit. Okay, then let us move on to where we ended off yesterday, 1.3. We finished the square pyramid, we finished the prism. Let us go on to example 12. Okay, on page 25, example 12. This one over here, we are combining what you have learned for angles of elevation, angles of depression, and bearing. Previously, we have always been dealing with physical shapes, like maybe a cuboid, a pyramid, something that you can actually look at. But if we give you bearing problems, we add in your angles of elevation and depression, it requires you to imagine a bit better. So if you're not good at imagining, then you need to draw it out, which I always draw it out. Okay, so in the diagram, TC, based on your question on page 25, TC is a vertical building. If you cannot imagine vertical building, take a pen, pencil, put it on your table, vertical. That is your vertical building. Then 3 spots, A, B, and C are on the same horizontal ground, with A due south of C. A due south of C. What does this mean? Can you show me what this means in a diagram? A is south of C. B due east of C. What does this mean? Show me your diagram and then you show it to me and see whether you really understand or not. What do these two lines mean in your diagram? You can just draw in your diagram. Huh? You don't have to draw the whole diagram. The diagram is already given to you. I just need you to show me what you understand by A is due south of C in the diagram as given. And what does B is due east of C mean? Yes. Think of where the angles. Go to see some angles. For example, A is south of C, right? That means it is that there is an angle that you can form from the north pole, the north direction that is given in the question, to somewhere else. What is that angle over there? If something is south of something, what is the angle? 180, right? Where is this 180 in your diagram? That's what I want to see. And then B is due east of C. So this means that there is a 90 degrees being made with the north direction. Okay? Show me your diagram where try and explain to you. Some of you are confused, and which is understandable. Because when we say that something is based on these two statements, A is, if C is over here, then A is over here, right? A is south of C, right? A is south of C. And I can draw this angle over here. Okay, this is 180 degrees. And then another thing is B is due east of C, meaning I can do this. And over here I have B. So this over here, 90 degrees. Alright? Alright, everybody look at the screen. Look at the screen. Is this diagram correct? B is east of C. That's a 90 degrees over here. A is south of C. That's 180 degrees over here. Correct or wrong? Correct, right? But in your diagram, if they drew it this way, how do you expect them to draw the vertical building? Right, there's a vertical building called CT, right? So the vertical building CT is perpendicular to this A, B, C, which is flat on the ground. So if I were to put this flat down, then the building will be sticking out this way, isn't it? Oh, but because they cannot give you a 3D diagram they cannot give you a model during your exams, they drew it in a way in your textbook. So if that is a drawing of a 3D diagram, that is why you don't really see all these very nice 90 degrees and 180 degrees in your textbook. Rather, what you saw, what you had given to you is something that looks like this. Yes? They will draw 3D. They will give you something that looks like that in your textbook. Okay, so let me explain what this means. This is our north. This is point C, point B, and point A. Okay? I remove the vertical building because that is the one that is confusing you. So right now I'm left with these 3 points. Where is my 180 degrees? Over here. This is 180 degrees. This is what I wanted to see in your diagram. Okay? Then what can you tell me by B is east of C? There must be a 90 degrees being formed between the north direction and BC, meaning over here. This is our 90 degrees. So, of course you must know. North, south, east, west, they are divided into 4 quadrants, 90 degrees each. Okay? So this is what I want to see in your diagram. But they had more items lah. So what else did they have in your diagram? So because they had to draw a 3D diagram, it ended up looking like this. Sorry, no arrow. This is the vertical building, T. Then so this vertical building is perpendicular to the ground, isn't it? Make sense? Buildings, they're all perpendicular to the ground. And where was my ground? My ground is where A, B, C lie. So this whole thing, I'm going to highlight the ground. Let's highlight green color. Let's say it is on grass. Oh, this is the flat ground. Then I have a building that's sticking up. Sticking up this way. The building is perpendicular to the ground. How do I illustrate that it is perpendicular? I draw right angles. So look at the red color one. This building is perpendicular to this line. Can visualize this? Are you able to visualize this? If you cannot, take your pencil, put it on your table. Then you can draw the line AC. Draw a line AC on the paper. Okay. In fact, everybody, let's just do that. Take a pencil, ruler, draw one line, call it AC on your textbook, wherever there is space. Just draw a line, label it AC. Draw a line, label it as AC. Just draw a line anywhere, AC, okay? Any space, I don't care about the orientation of your line, it's slanted, whatever, as long as it's a straight line. AC, label it, label it. Done? Now I want you to draw B. Draw the point B on the same diagram and join up BC. You understand? Basically just draw this, okay? Draw this on your textbook. Okay? Draw this on your textbook. Exactly what is written on what is drawn on the screen. That's where we need to use our pen, pencil to help us visualize. Okay, done? All done with the drawing? Okay, now take our pen, place it at point C, make it stand. Make it stand on your drawing. Okay, then you look, make sure it is vertical. Okay, your one has it, but it's dropped already. If you can leave it there, it's even better. Then you go your way. Actually, this guy look at the advanced diagram over here. This building is vertical. If you cannot see, please come over. Don't waste time. We don't have much time already. Otherwise, I just continue on. So everybody can see what is drawn on its textbook. What is the angle between this green pen, the vertical building, and the line AC? What is the angle between this green pen, which is the building, and the line AC? 90, right? 90, right? So I can draw, I illustrate with that kind of square to say it's 90 degrees, right? So I will have to draw it over here. 90 degrees, right? But I can't do it in the air. So when it's translated to a diagram in your textbook, you see that there is a 90 degrees over here. Understand? Understand? So with the same pen, what is the angle between the line BC and this vertical building? Look at your own diagram. Look at your own pen that is sticking out. What is the angle between BC and your pencil? 90 degrees again, right? Understand? Anybody still lost? Are you lost? That's what we are training your brain. Okay, this one requires practice. You need to try and visualize, see it from different angles. Okay? And when in the diagram, we draw in the building, it unfortunately will look like this, which could be misleading. So if that's the case, you go and, during the exam, go and stick your pencil there, try to understand what's happening. So, since everybody agreed that, class listen, everybody agreed that the building TC is perpendicular to AC. So that is why we had this drawn in your diagram. Can you see that in your diagram? Right? So this is what it means. At the same time, TC is also perpendicular to BC. Because you have all tried it already. That's why they had this one. Do you see it inside your textbook? Understand the diagram already? Understand how is it a 3D diagram? It is no longer those kind of 2D diagram, north, C, and then B over here, and A. These are different. This is 2D. This is 3D. It is a combination of 2D diagram and the concepts that you learn in angles of elevation and depression. Then you combine that into your 3D diagram. Okay? Okay, let us continue to understand this question. Now, the angles of elevation of T. Angles of elevation of T from where? From A. Where is the person's eye? Yeah, the person's eye is over here. What is he looking at? T. So we join this. Understand so far? Understand? He is looking at T from A. What is the angle of elevation? What is the angle of elevation from the question? 27. Where does it start? Angles of elevation always start from the horizontal. Where is your horizontal? AN or AC. Okay? So this angle over here is 27 degrees. Understand? And then we also have the angle of elevation of T from B. So B being here, the person's eye is over here, looking up at T. This is our angle of elevation, that is 56 degrees. Find the height of the building. Okay, so how to find the height of the building? Anybody wants to give out already? Huh? Still can follow, right? I think we are progressing slowly. We can still follow up. How to find the height of the building? TC. TC. Pythagoras. Trigo ratio. Where is the triangle? This kind of complicated diagrams, we can always simplify, isolate one triangle only. The triangle is this one. Can you see this triangle? Can you find this triangle in the diagram? Yeah, once you have that, then you can do it already, right? Trigo ratio. So, the whole trick to doing 3D diagram